What are some of the mathematics, the mathematical thinking that kids are doing when they're playing this game?
Oh, there's a ton, especially for the, well, even for older kids, and you can modify the game, but especially you notice it with the little ones. Initially, there's setting out the numbers in order. And in some sense, just knowing the number words, the number sequence, not the counting part. That's almost mathematics. That's a little bit more like language. It's a piece of poetry that they've memorized. 1, 2, 3, 4. But then recognizing the numerals, also not exactly mathematics, it's more like literacy. But knowing what these are, being able to use them, that really is beginning to get to the mathematical stuff. If we're using these cards and the configuration of dots exactly matches, the kids don't necessarily see that, especially in the beginning. And the 6, if you hold it the other way, it actually doesn't match. So some of it's the counting, and you can see whether they do recognize the number, the subbatize, and instantly look at that and say, oh, that's 4. Oh, that's 5. They often don't know the sum, but you can see if they do. It'll be common enough when we get a pairing like this, 2 and 1, that the kids, even some little kids, will say, oh, that's 3. But you'll see whether they're going 1, 2, 3. You'll see whether in their counting, we just watched a little boy who was counting a 6, I think he had a 6 and a 5, and he counted the 5 very accurately, and then when he went to count the 6, he only saw 4. Don't know what the error was, so he had to count again and get the 6. And then there's a bit of strategy in the game. I mentioned your goal is to get all your cards over. So let's see, with a 5 and a 3 that I've got, let's make it actually something else. There was a little girl who did a 4 and a 2, had a little 4 and a 2. There, it's 4 and a 2. With a 4 and 2, she quickly recognized the 4 and the 2. She didn't count. And she could count to get 6, or maybe she even knew it. But you have a choice. You want to turn over your 4 and 2, because that's what you see, or do you want to turn over your 6? And it's astonishing how pulled the little kids are to doing the adding. That's, I'm guessing, I don't really know, because it's the frontier of what they can do, that they get pulled to it. Kids always set themselves harder problems and harder tasks. That's probably why they skip on the road instead of just walking. It's harder. But keeping in mind the goal of the game, they might actually deliberately choose this. And if they don't, later on, after they've turned this and they get something like this again, they have to remember, here's another one, 2 and, let's see, well, we don't have enough cards over to 2 and, yeah, I don't have enough cards over, 3 and 3, there. I can't turn the 6. I have to do something else. And they might well forget the rule that they're allowed to use just what they say and turn over a 3. It's interesting that when we get, here's another one, we count it up, we see that we've got 7. One child turned over the 7 and turned it back and looked at it and said, it's not the same. And the teacher asked, well, can you still do it? Well, it's 7. So this is 5 and 2, that's 4 and 3. So you begin to get this idea that you can do different kinds of pairings of numbers to get 7.